Good evening, everyone. Thank you for joining our meetup today. We are the Our Ladies Abuja, and today is a special one for us. But before I introduce our speakers, I just want to thank everyone that joined on time. Thank you for sticking to the time, 5 p.m. So a little about us, Our Ladies Abuja. Um, we have about 6 organizers here that try to keep the group going. We have Billy Kisu, who's a data scientist, Queenet, a food technologist, Zinat, a public health specialist, myself, Ifoma, I'm an epidemiologist. We have Mabel, also an epidemiologist, and Abiodun, an epidemiologist, and Isika, a big data analyst. So we try to organize meetups to where we can learn, collaborate, and have fun together in the group. So this is one of our meetups today. And we have a very special guest joining us today. It's Julia. Julia, thank you so much for honoring our invitation. We are really thrilled to have you with us today. So a bit background on Julia. I'm sure we're all wondering. Of course, we've seen her work, watched her on YouTube. She's a data scientist and an engineering manager at Posit PBC, where she leads a team of developers building fluent, cohesive open source software for data science in R and Python. She's a tool builder, author, international keynote speaker, and a real-world data science practitioner. She holds a PhD in astrophysics and has written books with her collaborators about text mining, supervised machine learning for text, and modeling with tidy data principles. So happy to have you here, Julia. Welcome once again. So today she'll be taking us on outgrowing your laptop. I'm sure we've all seen the new ID Positron, so she's here to take us on that and speak to us on it. So welcome once again, everyone. And Julia, I'll stop sharing so you can share and take us today. Thank you so much.
Wonderful. Thank you so much for that introduction. I really am so happy to be here and I appreciate the invitation so much. So, I will just, in case you want to follow along and you're here, I will just drop the link here to my slides. But I'm very happy to talk to you here today about outgrowing your laptop because like you mentioned in the introduction, my background is in physics and astronomy. And when I was like in the research world, I did some work using remote servers where different data sets were. And then I transitioned into working as a data scientist, and I you know learned about infrastructure that was specific to like the company that I worked. It's like, oh yeah, like we have so much data and we can't have it on the laptop, right? It's in this database. And then now what I do is I work at Posit building tools for data scientists. And now thinking about this more, and as I kind of think about this arc, like my own sort of learning and background, when I learned about these things, like how to work beyond your laptop, like the computer that's right in front of you, I often learned about it in like an apprenticeship model or learned about it in a way where I thought what I was doing was very specific to the particular organization I was in. Like, where is the data in this? When I work at this university, where is our data coming out of the telescope? Or like I work at this company, what are our databases like? And I so where I am now, sitting where I am now, I look back and I think, oh, those things were all connected. Those were technologies that had overlap with each other. Those were different ways of working that I perceived as very separate and specific, but actually they're related to each other. So I'm really excited to talk to you about, to talk to you all about this today to help kind of draw some connections between these different ways of what we can do when we need to do something more than than what is capable on our laptop. So I am going to be talking about how to do this in Positron. So Positron is a new next generation data science IDE. So at my company, we what we care about, what we build is like tools for data scientists. We're the company that built RStudio, and now we're building this new IDE. So it is an IDE that has some differences from RStudio. It is built on top of the open source core code OSS that is used to make VS Code, but it is built to be data science specific. It is also polyglot or multilingual by design. So it is built specifically for data science, but it's not built specifically for R. It's built to do data science with R or with Python, or we can extend this to other languages in the future if they become important. So it is built specifically for data analysis, statistical modeling. It's not a general purpose software engineering IDE, but it's not specific only to R. We expect it to work great for R, but it's something that also you can use in other languages. Like specifically right now, it has support for R and Python. It is both familiar and extensible. So it's familiar in the sense that like we are the people who built RStudio. And so if you as our users if you started out using RStudio, we have the same sets of priorities in terms of like what makes a really great data science tool. In fact, there are literally some of the same people who worked on RStudio are now working on Positron on making it this great tool for data scientists to use. So it should feel familiar to folks who come from something like RStudio. It is also extensible in a way that RStudio never has been and is not possible to be. So Positron, since it's built on this open source core code OSS that we forked and then said, we're going to take this and make it into something specific for data science. It works. It supports the use of VS Code compatible extensions. So the ability to customize RStudio is somewhat limited compared to the ability to customize and extend Positron. And that can be everything from the most complex themes you can imagine to extensions that are about, say, accessing certain kinds of data platforms, or like there's a really huge world out there of extensions that Positron allows you to access in a data science specific IDE. I think we're here at the Our Ladies meeting, and so we're mostly our users, and so you may be wondering like, what is happening to RStudio? Do I need to switch right now? Is RStudio going away? So RStudio is not going away. Our company, our studio still has millions of users every week, and it's important to our company, it's important to our business, so RStudio is not going away. And in fact, we're continuing to invest in RStudio, both in terms of maintenance and even adding exciting new features to RStudio. So I would say if you are really happy with RStudio, then you shouldn't feel like you have to switch. You shouldn't feel like you need to or have to switch. I think you should consider switching if there are features in Positron that are not available in RStudio that would be a good fit for you. And actually, we're talking about some of those today. Some of these ways of working beyond your laptop are things that are only available in Positron and not available in RStudio. So that's a little bit about Positron. So that's what I'm working on now, full time, is working on Positron, or mostly full time, I guess. I still work on our packages here and there and whatnot. So I wanna for us to talk about where we usually start. Like when we work when we start to learn R, like say if you take a class like a statistics class in college, or a data science class, or you start working in a research lab and your advisor says, we use R here. Here's how we get started. Almost all of us start with a situation like this. So you've got a laptop or a desktop like in front of you, and on that let's say laptop, say on that laptop that you have in front of you, you install an IDE like RStudio or Positron. You install R there, and then you might have a CSV file that's maybe right there on your computer. It is stored on the hard drive of your laptop there. And you open up Positron or RStudio, it starts the R session, and then if you want to read in the data, it reads in R, opens the file and reads the data in, and then you can see it in the IDE and whatnot. When we're working in this mode, we might write code that looks like this. I have written code that says read CSV to like read in this file that's on the hard drive of the laptop. And then I might write code like this, like group by, summarize, arrange. This is tidyverse code, but if you use another paradigm for writing your R code, it's conceptually about the same. What I want to highlight here is that your uh, your your R installation is on the same computer that has the CSV file, and it's getting read directly in like that. And then the CSV is the data from the CSV is in memory in R. Like the whole thing is in memory in R all at once. If you're using an IDE, you might see something that looks like this. So right now here, I've got my console over there on the right. You can see I've executed this code, group by, summarize, arrange. That code is being executed on my laptop, in the R that's on my laptop. And then I have opened the Data Explorer, Positron's Data Explorer, and I'm looking at that data frame, and you can see that I can see the distributions that I have for these variables. I see how much missing data is there, and I can scroll around here in the Data Explorer. And as I'm looking at this, everything that I see here is in memory in its entirety in R. And if I make a plot here, like as we see down there on the lower right, that plot that I made was made using data that was totally in memory. Though this was like a group by, summarize, arrange for this type, for these Pokemon. And if I made a plot here, so the whole data set of all the Pokemon was in memory, and then I did the group by and summarize directly in R, and then I made a plot using that. So this is how we usually start. And some of you might be thinking, why are you talking about this? Of course, like this is confusing that you're even trying to talk about this, but I want to talk about like where is the data, like where is the file and where is the data, because it can then tell us like help us understand the kinds of tasks that we want to do to move forward from there. So I think this is a great place to start. And if you're, anytime like I teach learners or like I hear about like people getting started with R, I think this is great. This is like a really good place for pieces to start. I'm not making any kind of point that this is bad at all. Like this is good and a good place to start. And if for many use cases, it's actually enough. Like it's actually enough to be able to work with CSV or Excel files on disk and to be able to do your analysis in memory in R. However, it is not uncommon to start to run into problems working this way. And there are mainly two categories of problems that people tend to run into. The first one is problems with memory, meaning the computer that you're working on doesn't have enough memory to hold the data set as a whole in it, or it doesn't have enough memory to hold the data set and do something else like group by summarize or train a model or something like that. So the first category of problems we can run into is problems with memory. And the second category of problems we can run to is problems with performance. Things take too long. You try to train a model and there's just like too much data. It just takes way too long to finish. Or maybe, with the example of a group by summarize, maybe the data set is so big and there are so many groups, like maybe there are so many groups that process of trying to do group by summarize is really slow because there are so many groups and so much data. So your laptop is a great place to start, but these are the two kinds of problems that often come up for people, and they think, "Oh man, what am I going to do? What am I going to do here? How am I going to take a next step to be able to do the analytical work I need to, or the statistical work that I need to?" So in this talk today, we're going to step through where do we go from here? Like, what are kind of some of the options? So this is the outline for my talk here. So, we start with a CSV file. Then I'm going to talk about how we can use Parquet files with DuckDB. Then we're going to talk about databases, and then we're going to talk about remote SSH sessions. So I have these in order, but it's not exact. And this, I acknowledge that this meme using this meme like this kind of implies that this is like going from worse to better. That's not quite right. These things are different from each other, and you might choose one over another depending on, the organization where you work and what the constraints are, or like there are different trade-offs here. So I am going to talk about these in this order, but it's not exactly right that as you need more and more memory, you should move through this as a like sequence. That's not exactly right. These are all kind of different from each other, different, related, and have different sets of trade-offs. So let's dig in. So we started with CSV, and the first thing we're going to talk about is just moving to a different file format. So instead of reading a CSV file, what if we start by reading a Parquet file? So Parquet file is a file format so it's also a file that is on a hard drive somewhere, right? Like it's a whole, it's like maybe a single file, a single Parquet file. It's different from something like a CSV file in that it is a binary file format. So you can't like open a Parquet file in a text editor and literally see rows. It's a binary file format that's specifically built for analytical tasks. So it's built for rectangular data, and it's built so that we can get access to the metadata about the columns, say like the column names and types, and what like a little bit of some previews of what's in it without actually having to load the whole file into memory. So Parquet files are files for rectangular data that are built specially to be able to deal with the data that's in there without having to read the whole thing at once into memory. So, if you're using R and the tidyverse, you don't have to change the file that you are sorry, you don't have to change the code that you write that much. So before I had read CSV, and now I'm going to use read Parquet DuckDB instead. So, and then instead of doing group by, summarize, arrange, in here I have summarize by month and arrange here. So we can, if we want to do the same kind of task, say like a group by, summarize, arrange here, I can do that with very similar code. Not a lot changes in the code I write, but I want to highlight some things that are different now. So when we do that read Parquet DuckDB, it is not actually reading that whole Parquet file into memory at one time. Instead, what it's doing is it's getting metadata about what's in the Parquet file so that we can execute queries against it. So that df object is not truly an R object that contains a whole tibble or data frame. Instead, it is a lazy data frame in that it acts somewhat like a data frame, but it does not have all the data in it. And when I do summarize by arrange here, the output that I get here is actually still not all in memory in R. There's like two variables here, and you'll notice that it is not quite sure how many rows are. It doesn't tell me how many rows are in there. And that's because this whole thing has not been brought into memory in R. If I want to bring it over into memory, then I take the collect step. And so notice what's different here. Here it says, this is a duck plier data frame. And now it says, now this is a tibble. So the difference when you say collect, that means materialize the query and really bring it into R. Like I no longer want to do these lazy evaluation kinds of things where we haven't really done it yet. And now I really do want to bring it into R. So when you work with lazy evaluation with something like DuckDB here, it lets us write code to, as we're quickly iterating to like figure out what the query is that we need to do. That part's really fast, and it doesn't really start to get slow because there's a lot of data until we do the collect state. And so this setup, lazy evaluation with DuckDB and Parquet actually helps us solve both problems about memory and about performance. So it helps us solve the problem of running out of memory because we don't actually have to read the whole file in. We can summarize, maybe go from something with millions of rows to a more summarized data frame like this one here, where it's like for every month, what is the delay? Like for every given month, what's the delay? We don't need to run out of memory because we are able to push the query down into the DuckDB query engine and do it against the Parquet files there. It also solves problems around performance because the DuckDB query engine is really efficient. It's really fast, screaming fast, one might say. So it solves both the problem around performance and the problems around memory, which is really exciting to be able to know about this. So I talked about this sort of setup here, where instead of a CSV, we just swap in a Parquet file, which lets us have um, less challenges around memory and performance. But it is also possible actually to work with Parquet files that are not on your laptop. For example, the R session can connect to, say, an S3 bucket, some kind of remote server or machine that has the Parquet file on it. And instead, we're starting to move up in complexity of like, where are the files? How are we executing it and whatnot? So if we wanted to work in a situation like this, we again can write pretty similar code. So here, this is a set of example Parquet files that DuckDB makes available, and they're at this. There's like files here for multiple years for 2022, 2023, 2024. So I can read in a whole vector of Parquet files, and then I can still do my summarize by arrange here. So if we are going to work with a remote Parquet file, that's actually pretty straightforward here. We can write, in fact, the same kind of code that we would in if it was just local on our machine, which is really exciting to be able to step forward in that way. When you're working in an IDE that with situations like this, so here I'm working with the S3 with the Parquet files that are in the S3 bucket, like far away like this. You'll notice that there are some things that happen in the IDE that help me understand what is going on. So for example, if I print out df. So df, I did read Parquet DuckDB for this vector of Parquet files. It is helping me understand what that data object is by telling me, it's a duckplier data frame. It's not yet a tibble or a data frame in memory in R. And I want to highlight your attention over on the right in the variables pane. Notice how under data, look at df there. Notice how it says question mark rows. Question mark rows. And that's because we have not brought the whole thing into memory in R, and we literally don't know how many rows there are. We have a sense of a preview of what is in it, right? Like we have metadata on the columns, but we don't actually know what the number of rows is. And if I were to do this summarize by and arrange here, and to get out just 12 by 2 numbers, only 24 numbers, that's when I finally bring it into R. So the big data, the row level data that's there in DF, I don't bring that into R. And instead, what I bring into R is just the summarized data here that I can use to make a plot. So here we're looking at the delay over in the different months here. So now when you start to work with this kind of lazy evaluation, I think there are some things that are helpful to keep in mind. And the first thing is to kind of understand what the terms mean. There's some like terminology around this stuff. So DuckDB is a query engine. So it's a piece of software that helps you execute queries. It works really well with Parquet files. Parquet, that's a file format. It's like a way of saving things to disk. So like a CSV file or, an Excel file or something. Like a Parquet file is a thing that is on a disk somewhere, and DuckDB is a query engine. They work amazingly together. Like they're like that sort of combo is really great in terms of like usability, the things you can do with it. But DuckDB is a query engine, actually can execute queries against a bunch of stuff. It actually knows how to do queries against CSV. It actually knows how to do queries against many databases like SQLite or Postgres or things like that. So DuckDB is a query engine, and Parquet is a file format. So it's helpful to have clarity about what these different kinds of terms mean. The second tip is that working with lazy queries can really take some getting used to. If we start out being used to everything being totally in memory in R, this workflow of actually working with lazy queries, it can take some adjustment. It can really take some adjustment. I think a very common experience for people is I'm like writing my queries lazily, and it's going so fast. Like when you execute the lazy queries, it's like incredibly fast. You're like, oh yeah, yeah, return right away, even when your data is enormous. Again, because it is not executing the queries in whole. It's just like previewing it effectively. And then you're like fast, 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 fast. And then you accidentally do something that materializes all the data into R. And your R and your whole IDE just like comes to a screeching halt, and maybe it crashes and you're like, oh no. Like that's the kind of thing that happens when you accidentally materialize a large data set in R, because and it can kind of trick, can kind of surprise you sometimes if you don't have some if you're not as used to what it's like working with lazy evaluation and lazy queries. Another tip that I want to share is that I showed writing very tidyverse style code, dplyr style code. And that's because there's this translation between dplyr and the underlying DuckDB query engine. There's this like translation layer there, and that is amazing. But not everything is supported. And so it's good to understand that you're writing code and it's getting translated to something that the query engine knows about. You probably noticed that I wrote here I'm writing like summarize by instead of group by summarize. And that's because not everything is supported in that translation there. So it is good to understand, even if, you're not going to learn every single thing about the DuckDB query engine, it's good to understand how that translation happens. If you do need to read or write Parquet files yourself, I would recommend that you try out the Nano Parquet package. So this is a package, it's not a package that understands about the query engine, like summarize by, arrange, select. It doesn't know about those things. It's like a nice, fast, lightweight package for reading and writing whole Parquet files. So if you needed to really, really write the whole thing with something that's in memory in R, I really recommend looking at Nano Parquet. It's like a different, set of tasks. It's like only reading and writing, not doing the queries there. And then the last tip that I have here about working with DuckDB is that once files are no longer on your laptop, like once they're somewhere else, an S3 bucket, a remote server, like somewhere far away, often the hardest part is not writing the R code, doing the analysis or stats. Often the hardest part becomes authentication. Like that can be, it can take a certain amount of grit and stick-to-itness to be able to like get the auth figured out there. It often becomes that's the difficult part rather than the actual analysis that you want to do. All right, so we started talking about CSVs, and that's a great place to start. We moved on to talking about parquet files using together with DuckDB. So yeah, we started at CSV, we talked about parquet and DuckDB, and now let's talk about databases. So databases, if we make a little mini architecture diagram here, it looks pretty similar to the parquet file that's on a remote server. On your laptop, you have your IDE like Positron or RStudio, and your R session is there on your laptop there, but the data is in a database that's far away, not on your laptop. It's on a remote server somewhere. So a database is different from a parquet file in that it's usually it's not one file somewhere. It's like a bunch of files with some software around it that knows how to deal with the files. And typically they are, you would not typically have a whole database on your laptop, right? Like it's somewhere else that you can go there and query it. Databases are honestly so cool. Like there are whole like academic research areas about why our database is great and like how do you make them and how do you build like the query engines for them, like so usually a database will come together with its own query engine so that there's like rules for how you can like do, like how do I get data in and out of this kind of thing here. So databases are really cool. When we deal with them from R, we often will write code like this. So we start by making a connection. And so a connection is an R object to some kind of a database that would be somewhere else. So it's a R object that contains the rules for how we connect to it and how we get data in and out. So here I made a connection, and then databases typically have multiple tables in them. So here I'm going to say, okay, go to that connection and get me the flights table. There may be many other tables that are in there, but like let me get the flights table. And once I have that, I can group by summarize. I can do like a group by summarize here. Similarly to when we were using a parquet file, this has not been brought into memory. This has not been brought into memory in R. It is a lazy query. And similarly to in the with the parquet file, if I did want to bring it into memory, I would use collect. So collect is this verb that means instead of giving me like a preview of the data that is far away in the database here, it says like database, SQLite, et cetera, et cetera. Notice it says question mark by 2. It doesn't know how many rows there are yet. It doesn't know how many rows. And then once I collect, now it's a tibble. Now it's an R object. Now it does know how many rows it has. Now it does, because now this thing is totally in memory in R. So again, working with databases is great because the DF here could have millions of rows. It could be across who even knows how many files inside the database, right? Like it could be many, many rows. And then the database knows how to group by and summarize. And then if I need to do something with it in R, like say I need to make a plot or I need to train a model in R, I then can collect in here. So once again, this solves problems both about memory and about performance because the big data set is in the database. It's not in memory in R, and I can structure my analysis so that I don't need to bring the whole thing into memory in R. In this example, say I wanted to make a plot here of the delay over the months of the year. I don't need every row. I need a value for every month. And so it solves the problem of memory by pushing the row level analysis down into the database. Database, it also solves problems around performance because database query engines are built to be super efficient. Like they're optimized for exactly doing this one thing, like executing queries. And that is It's really good at that. And so it is much faster than, for example, trying to use R to do a group, or Python or anything like that. Like it's much faster for this database to do the query engine. There is a great question here in the chat about when do we need to collect? And so I think the great thing to think about is you need to collect anytime you need R to do something. And so often that will be, I need to train a model, or I need to make a plot, or like I need R to do something. So you want to push all the query parts, all the group by, summarize, select, like all that kind of like query stuff you want to push into the database, and you only want to bring it into R once you have a summarized data set that you want to do something and go like sort of take some step next from there. So this is so there's a question also about dtplyr. I believe that's a data table backend for dplyr, and the dtplyr can solve performance problems because it uses a very fast engine, very fast. So dot table was built to prioritize performance, and so a dtplyr is like a translation from dplyr to data.table. And so that you still have to have everything in memory in R, but it can get you speed ups compared to raw dplyr. Although dplyr itself has seen some really great improvements, performance improvements also lately. So when you're working with database connections in an IDE, like say Positron, again, there's like clues and UI components that help you understand what it is that you're dealing with, and helps you be able to like work on some of these things. So I've got my script here. I'm executing it in the console. And here what I have is a group by summarize, and notice what it says here is um, the source is SQL, and it doesn't tell me yet that it is an R object. Like, it's how it's printing out is helping me understand what kind of object it is. Positron also has a connections pane, which lets you visually explore what like what's available. So here I've got a connection to a SQLite database that I'm dealing with and scrolling around in. And in this example, I got the flights table out of it. But you can see there are other tables that are in this database, and I can explore it, and I can understand what columns are there. And I can, if I like click the little icon that's like the grid, I can actually get a preview of it in the data explorer, like what I showed you before with the CSV file, with the R object. So, and that gives me this preview view into what the database is like what's the table like, what's it in, but it doesn't bring the whole thing into memory. Like, it does not bring the whole table into memory. It just gives you a preview there, which is what you want. All right, so if you're working with databases, I've got a couple tips. The first is that it's worth learning a little SQL. Even if you use dbplyr, which is what I showed there. So dbplyr is this translation between dplyr and the underlying query engine. So it's worth, if you are working with SQL databases, it is worth understanding a little bit about how SQL works, because dbplyr is amazing. I love it. It's my preference when I'm working with databases. But if you don't have any knowledge of what's kind of going on with SQL, you can sometimes get surprised by things, because like the translation between them is amazing again, but like it's not really one-to-one because they are doing slightly different things. Once again, I'm going to say that working with lazy queries can take some getting used to. Like, lazy queries can take some getting used to. If you're, again, you're like you're executing code really fast, and you are it gets returned to you really quickly because it's just giving you these little previews, but then you accidentally do something that materializes the whole thing. And in this case, actually, if that's a database that other people use, your giant query can actually block other people people. So working with lazy queries can take some getting used to for similar reasons, but actually when it's a database, you can have more people around you getting annoyed because what you are doing can like slow down that database for other people as well. So it definitely takes some getting used to working with lazy evaluation and these kinds of queries. Again, this translation between dplyr and SQL is really amazing, but sometimes there are some subtleties that come up. And so if you want to, this is a link that you can click through and you can like see what some of those subtleties are there. You can also use that connections pane that I showed you. This thing over here on the right, you can use that with DuckDB because DuckDB is a related technology. It's a query engine. You in fact can you do that. You can actually like do DuckDB and connections pane and to use it to explore things that you see here because these are not like separate kinds of ideas. They're kind of different flavors and tools and ways of working that are related to each other. When working with databases, often the hardest part is auth. When you, for example, are working like once you're working with a database and you have you're like writing R code, maybe you're writing dbplyr for all of your queries and whatnot, and you're like, oh, this is so great. Often the hardest part when you're working with a database is just even making the connection successfully to start with, because there are all different ways of authenticating to different databases, and so that authentication piece is often the piece that actually causes the most pain relative to actually doing some analysis there. Okay, so we talked about starting with a CSV file, which is a great place to start. But once we start running into problems with performance and memory, we can move on to other tools. We talked about Parquet and DuckDB. We talked about databases. And now I'm going to talk about remote SSH. So this is a little bit more different than some of the other things that we've talked about so far. So if we make a little architecture diagram of what's going on, what is on your laptop in this case is only the very front end of Positron. It is only the UI, just like the very, very skin, like the very front end of Positron is what is on your laptop. And then it connects over an SSH connection to another remote server. And the remote server has the Positron backend on it. And R is no longer on your laptop. Now R is on the remote server, and then your files are over there on the remote server. Maybe it's the database, maybe it's Parquet files, like that stuff is all over far away. So I want to highlight that this is different. Instead of having R on your laptop and you're connecting to other things like Parquet files and databases, now R is on the remote server, and there's a connection for you between the front end of Positron and the back end of Positron, which is the part that runs with R. So this also solves the problems around memory and performance in the sense that that remote server can be as beefy as you want it to be. Like you can connect to a remote server that has that's a high performance computing cluster. Like it can be something that is an EC2 instance from S3. Like the thing that you're connecting to can be as powerful a computer as you need it to be. So you don't have to be connected just to how powerful your laptop is. Your laptop that you carry around with you can be kind of your gateway to very powerful computers that you can connect to on the back end. So it can be enormous memory, enormous performance. So it solves those problems by letting you get a convenient way to deal with a very powerful computer, a very powerful machine that is remote somewhere else. So when you're working with remote sessions with Positron, you'll see something that looks a bit like this. I want to highlight that in the bottom, like in the bottom left down here, it's telling you that you're connected to a remote session. It says SSH flights demo. Now, when I want to highlight what's happening here is that that file is not on my laptop. That file is on the remote server. And in this case, that flights parquet thing is on the remote server. It's no longer on my laptop. The R that I'm running here is not on my laptop. The R is on the remote server. And this plot that I made is made with data that is on the remote server. If you come over here and you look at ports, this is like telling you how things are getting connected. And like, so there's a bunch of ports open between the front end that is on your laptop. And then all these ports are open to the back end that's on the remote server. So this is a way of working that really opens up a lot of opportunities. And this is something that is not possible to do in RStudio and will never be possible to do in RStudio given the architecture of RStudio. So this like being able, wanting to do this kind of thing would be a reason why you should consider switching to Positron away from RStudio, because this is an example of a kind of feature that is only available in Positron there. So I'll give some tips for remote SSH sessions. So keep in mind that your console, your terminals, your files, your extensions, they are all on the remote server. Like there are literally files that are not on your laptop that are on the remote server that you're able to interact with. So it's helpful to understand, have the correct mental model for where stuff is when you're working with remote SSH sessions. You can control how long your sessions live via this setting, the kernel supervisor shutdown timeout setting. And so what this means is if you have something like this, and then you start a model training, like let's say you start a long running model training in your console, you can actually, if you change that setting to be never or whatever, you can actually shut down Positron on your laptop. You can close your laptop. You can turn your laptop off, and the model will keep training remotely on the server that's going far away. So this really, you know, opens up the opportunities for conveniently working on some very long running things. You can use these types of remote sessions all locally with Docker. And you might want to do this for like reproducibility reasons. Say you want to have a Docker container that has very like it's exactly pinned to what versions of our packages, what versions of our like high reproducibility needs. You can use then the remote session to connect from your laptop to a Docker container that's running on the same computer. There's a great blog post from Andrew Heiss about how to do this. And this is, you would want to do this when you have really high reproducibility needs. You would not, this does not help at all with memory and performance, because in fact, now everything is a little slower because you're like running a little computer inside of your laptop. Like it's like a mini little nested computer inside of your laptop or desktop or whatever you're using. So that actually hurts you when it comes to memory and performance. But if you have high reproducibility needs, it can be a great option. I bet you can guess what my last tip is. I bet you can guess. When you're working with remote sessions, often the hardest part is off. Like so what you're doing when you should be able to use remote SSH sessions with any remote server that you can SSH into with pretty vanilla authentication methods. And trying to get, depending on if that remote server is like what its characteristics are like and how authentication is managed on it, like that can be a little bit tough to figure out. And often it feels like the hardest part is to get the auth working here. There's a question here in the chat about like how dependent is it on the internet? And it is 100% dependent on your connection. So here that SSH connection between the front end and the back end, that could be on an internal network, or it could be a machine that you are physically connected to, but most often that is an internet connection. Most often that is an internet connection. And so this is 100% dependent on how well your laptop is connected to whatever the remote server is there. So yes, absolutely. That is kind of the infrastructure that this is all built on, is SSH sessions there. All right, so if you want to try out Positron for any of these reasons that we talked about here, you can go to positron.posit.co to get documentation and installers. You can find us on GitHub at posit-dev/positron. This is a really great if you run into problems or you have questions, we encourage you to start in discussions in GitHub discussions. It's a great place to get help or to report bugs or to um, ask questions or whatever. You can use Positron in a server environment on Posit Workbench. So this is like another, if we were to make a little diagram of that, the only thing that would be on your laptop is a browser. And then in a browser, you would go to a server that has Posit Workbench and Positron installed on it there. So that's another way that you can use Positron and that in a way that grows beyond your laptop. This QR code goes to my slides here, and those slides and had a fair amount of links and things in there. And so if you want to check on any of that later, you can go here to my slides, and that will help you get more info. And with that, I'll say thank you very much. I'll leave this up in case folks want to use the QR code. Thank you so much for having me.
Thank you so much, Julia. It was a wonderful session. Thank you so much. Are there any questions for Julia? We have about 8 minutes before it's 6.
There is a question I think that came up a little. When you're done with data wrangling, you can continue. Yes, that's right. So yes, that person was asking a question about when you have those lazy queries and then you collect. So you do the data wrangling in the database or in the Parquet file, then you collect into R, and then you might do something that only R knows how to do, like make a plot or train a model or something like that. So yes, there's a question here about inline output in Quarto documents. That's not something that's currently available, but we're actively working on it. So so if you've worked in RStudio and you're familiar with that behavior where you have you're editing your file and you see results in the editor, like you might see a plot in the editor in a like notebook like way of working. That's not something that works right today in Positron, but it is something we're actively working on, figuring out how to get that going. I think that's going to be it's interesting, like thinking about the ways of working in like the different kinds of editors and execution models. Like, do you have like a R file and a console, a Quarto file and a console? Do you have a Jupyter notebook where you're executing inline, or a Quarto source file with executing inline? A lot of different sort of ways of working. So there's a question here about if I run a 1-hour model and the 59th minute my internet connection drops. So if you set that shutdown, if this setting right here is what controls how long the R kernel will run, like when will it decide to shut down? So if you have it set to something like immediately, then it will shut down immediately when you disconnect. But if you have it to set something like 4 hours or 8 hours or infinite, never shut down, then it will stay up as long as it can. And so it would continue to do the training and you can reconnect later. So this setting is what controls that question from Nick about if the internet drops in a remote session, what happens? A question, if I have big data in CSV, can I convert it to Parquet and then work with it? Yes. If it is not so big that it stops you from reading it into memory at all, you do it using R and the Nano Parquet package. So read the whole thing in R, write it out in Parquet, and then use the Parquet file for like really fast querying. If it is too big to read into R at all, then you're going to have to turn to other tools. Like I believe that if you were to use DuckDB, just not through R, but like use DuckDB itself, I think you could probably do it that way, like on the command line using DuckDB itself. And oh my gosh, someone got up really early to listen. Oh my goodness. And I think we've got some questions about the recordings and all that. Okay, great. Are there any other questions?
I think that's all the questions for now.
Awesome.
Thank you so much, Julia. Okay. Oh, we have.
One more.
Oh,
Okay, so this question is about R versus Python. Maybe this is a great one to end up on. Um, so R and Python are very similar in terms of performance. And so everything that I talked about actually applies to Python as well. You have the same limitations on memory. Python is not faster than R is. So Python does not help you solve the memory or the performance problems. So everything that I just talked about would apply the same to someone who wanted to try to do similar things in Python. Like going to Python doesn't help you at all, actually. You would have to do all the same things I was just talking about, like using DuckDB, you connecting to databases. So going to Python is not faster or more scalable than R. If the question is like, oh, I feel like everybody's learning Python around me, is it bad for me to not know it? That's an interesting question. And I would say that I'm, you might consider me mid-career. And I think my advice is that it's not realistic to expect to only know one language your whole career. Few people end up in that situation where they use just one language. I use Python and R for different kinds of things because I prefer them in different like situations. I'll always turn to R for data visualization, for like quick EDA, like being able to do exploratory data analysis, and I will always choose R for statistical modeling. But I think that being open to learning another language and kind of having that in your toolkit is probably a good career move because one language, your whole career is probably not realistic. But this question specifically was about performance, and R is not worse than Python for performance. All the things we talked about today would apply the same to Python.
okay. Um, okay, I think one more question dropped also. Okay, it's just another question. All right. Any more? So if not, to call it a day. Thank you so much, Julia. It was wonderful having you here. Learned so much. We get to apply it now in our work. Thank you everyone for joining, for responding, for signing up. We do have another webinar coming up next month where we'll put out the post shortly for that. The recording will be made available on our YouTube channel so you can go back and watch it again. So thank you everyone and have a lovely, lovely evening or morning wherever you are.
Wherever we
Thank
are,
you.
yes. Thank you for
Yeah.
having me. Thank you very
Thank you,
much.
Julia. Thank you so much. Bye
Thank
everyone.
you.